Hello everyone. Today we are discussing about Hopfield network. So what is Hopfield network? Hopfield network is a form of recurrent artificial neural network invented by John Hopfield in 1982. It can be seen as fully connected single-layer auto-associative network, that is, it is calculated by conveying iterative process, and it is commonly used for auto-association and optimization tasks. Hopfield network serves as a content addressable memory system with binary threshold nodes. So here in Hopfield network there is two main algorithms are there. One is training algorithm and one is testing algorithm. So what is training algorithm? Let us try to know more about it. Training algorithm for storing a set of binary patterns S of P where P is equal to 1 to P, where S of P is equal to S0 of P and S1 of P, etc. Sn of P. Weight matrix is given by Wij is equal to summation of P is equal to 1 to P to Si of P minus 1 into 2 Sj of P minus 1. For I naught is equal to J. For bipolar input patterns, Wij is equal to summation of P equal to 1 to P, Si of P, Sj of P. For I naught is equal to J. Weights here have self connection Wij is equal to 0. Okay, then we go through the next algorithm, that is testing algorithm. In testing algorithm there is 8 steps in there, and the first step is initialize ways to store patterns, and the second step, when activations of net are not converged, perform steps 2 to 8. Step 2, for each input vector xi, perform steps 3 to 7. Step 3, make initialize activations of net equal to external input vector x is equal to yi is equal to xi, that is I equal to 1 to n. Okay, step 6, applying activation over net input to calculate output, that is yi is equal to 1 if y in is greater than 0, y1 if y in is equal to 0 and 0 if y in less than 0. So where theta I is threshold is normally taken as 0. At the introduction part, we already told about Hopfield network serve as a content addressable memory system with binary threshold nodes. So this is binary threshold nodes. So step 7 is step 7 is now feedback or transmit the obtained input y1 to all other units, then activation vectors are updated. And the final step is step 8, finally test the network for convergence. Okay, the all algorithm and all steps are will become clear to you when we go through a problem. So we move to an example. So our example is construct an associative discrete Hopfield network with input vector 1 1 1 minus 1. Test discrete Hopfield network with missing entries in first and second components of stored vector. So here our input vector x is 1 1 1 minus 1. So we write it as input vector x is equal to 1 1 1 minus 1. Then what is the first step in our algorithm? The first step is initialize weights to store patterns. So here we initialize the weights. W is equal to summation of S of transpose of P plus P. Here X is equal to P. So we consider P as 1 1 1 minus 1. So transpose of P will become this, and P into transpose of P into P. So here it is 4 into 1 matrix, and this is 1 into 4 matrix. So when we calculating this, we will get a 4 into 4 matrix like this, and that is 1 into 1 1 1 into 1 1, like that we will get a 4 by 4 matrix. The next step is when activations of net are not converged, perform step 2 to 8, that is weight matrix with no self connection says upper. Okay, then what is the next step? What we were going to do next is write the diagonals as 0. Here the diagonal is the diagonal value is 1 when we write it as 0. So we get a new weight matrix. Okay, the next step is write the binary representation. So here the input vector is 1 1 1 minus 1. So what is the binary representation of this? The binary representation of the input vector is 1 1 1 0. That is the minus value we considered as 0. We can carry out updation of weights as letters y1, y2, y3 and y4. For input vector with two missing entries in first and second elements of stored vector. So what is our question? In our question, they say that Hopfield network with missing entries in first and second components of the stored vector. So here what is the first two components, that is 1 and 1. This we will consider as missing entries, that is. So our binary representation vector is 1 1 1 0. By the question, first and second two entries are missing. So we write it as 0 0 1 0. Okay. So then we move to the algorithms. Initialize weights to store patterns. So we initialize the weights. This is our new weight algorithm, and step 1, x is equal to 0 0 1 0. By the question, two entries are missing. First is two entries are missing, so we put as 0 0 1 0, and the y vector is equal to like this 0 0 1 0. Okay, then we move to step 3. Step 3 is choosing units y for updating its activations. So here the equation is y in 1 is equal to x1 plus summation of j equal to 1 to 4 yj into wj1. That is here. What is x1? Here our x vector is 0 0 1 0. So our x1 is 0. So 0 plus what is yj? Yj is this vector. When we consider y is equal to 0 0 1 0, so our yj vector is 0 0 1 0. Then what is wj1? That is wj1 is in weight matrix. The first column is called wj1. So we write the wj1. When we calculate this, we will get 0 plus this value is 1 is equal to 0 plus 1 equal to 1. So by applying activation function, y in 1 is greater than 0, that is y1 is equal to 1. In our algorithm, if y in is greater than 0, the value of y is equal to 1. So here the value we get y in 1 is equal to 1. It is greater than 0, so the value of y is equal to 1. So we rewrite the matrix as binary matrix as 1 0 1 0. So it is not in convergence. So we repeat the steps and choosing next y. So choosing units y4 for updating its activations. So we next take y4 to activation function. So what is the equation of y4? Y in 4 is equal to x4 plus summation of j equal to 1 to 4 into yj into wj4. That is here. What is x4? x4 in the new matrix x4 is 0. So 0 plus what is the y? Yi. This is the new yi matrix. So we write it as it. Then our wj4. What is our wj4? Sorry. In weight matrix we consider w4 is equal to J4 is equal to this fourth column of the weight matrix. So we write it as -1 -1 -1 0. that is minus 1 minus 1 minus 1 0. Then we calculating this, we get the value in value of y in 4 is minus 2. Minus 2 is less than 0. So what is the value of less than 0? If y in less than 0, the value of y is equal to 0. So we get y4 is equal to 0. Therefore the new matrix is y is equal to 1 1 1 sorry 1 0 1 0. It is not convergence. So the value of y4 is equal to 0. So when we get the new y matrix is 1 0 1 0. This is not convergence because what is our binary representation vector is 1 1 1 0. Here 1 0 1 0. So this is not convergence. To converge this, we go through the steps again. And step 5, choosing units y34, applying its activations. So we take y3 to activations. So y in 3 is equal to, what is the equation? Equation will become x3 plus summation of j equal to 1 to 4 yj into wj3. So here what is x3? Our new matrix is this. So in here x3 is 1. So 1 plus, what is yj matrix? Our new yj matrix is this 1 0 1 0. So we write it as write like this. And what is wj3? What is wj3? Wj3 is the third column of the weight matrix. So we write it as 1 1 0 minus 1. Then we calculating this, we get 2. So 2 is greater than 0. So what is the value of y3? By the algorithm, if y in greater than 0, the value of y is equal to 1. So the value of y become 1. That is y in 3 greater than 0. So the value of y3 is equal to 1. So we write the new matrix as y is equal to 1 0 1 0. This is not convergence. So because our binary representation value is 1 1 1 0. So we go through the next step. Step 6, choosing unit y2 for updating its activations. So what is the equation in y2? Y into is equal to x2 plus summation of j equal to 1 to 4 yj into wj2. So what is the value of x2? What is the value of x2? Our new matrix is this. So x2 value is 0. So 0 plus, what is yj? This is our new yj matrix. So we write it as, and what is wj2? Wj2 is the second column of the weight matrix. So we write it as 1 0 1 minus 1. So when we calculating this, we get the value 2. This is also greater than 0. 2 is greater than 0. Okay, so the y in 2 greater than 0. So the value of y2 is equal to 1. Therefore we get another matrix y is equal to 1 1 1 0. This is convergence because our binary representation value is 1 1 1 0 and we get also 1 1 1 0. So this is convergence. Thank you.